Hey everybody, Bill Sky, the FORTRAN guy, and this is our second video on functions. And today we're going to do a quick overview of statement functions. Now, as I may have mentioned in my first video on FORTRAN functions, statement functions are functions that are one line long. Well, maybe I didn't say that, but they're one line long, and they've actually kind of been deprecated. They're not gone. The compilers all support them, but they're not used a whole lot anymore on new code. However, on old code, they're everywhere. And I do see some benefit to them. They're actually very easy to code. Let's just jump right into it. This is just going to take a few minutes, and you'll learn all about statement functions. All right, so let's go ahead and create a new project. And again, I'm going to be using the FORTRAN compiler by Intel. And let's call this statement functions. All right. Now, as I said earlier, a statement function is simply a one-line function. There's no function keyword. There's no real heavy definition of it. And what I'm going to do is I'm going to define it right after my implicit none, which means that all functions are available. Anyway, so let's go ahead. I'm going to create a function called 3averages, or average3. So I could say average3. You simply put in the function name, you put in the parentheses, and this function is going to get 3 arguments sent to it. And what should this function do? Well, I'm simply going to add a plus b plus c, and I'm going to divide it by 3. That's all that function. That's it. That's absolutely it. So now I'm going to go over to my terminal, and I'm going to source the set variables for the Intel compiler. I'm going to make it. And, oops, what did I do wrong here? Let's take a look. Oh, the reason is because I never defined the variables. So let's go ahead and define the variables. So they're going to be integers. And then let's go ahead and execute it. So I'm going to say z equals average3. Let's do x, y, z. And I'm going to say print asterisk z. Okay, still having an issue here, so let's figure out what we're doing. So a, b, and c equals abc divided by 3. Let's go to the very top. Normally the very top of the compile will tell you exactly what's going on here. So it says main f on line 14. Yeah, it's not really seeing this. And it might have something to do with the fact that I haven't actually explicitly said what those data types were. So let's go ahead and put our integers above that. And we'll do another integer. And let's see if that fixes that. I'm wondering if it's the Intel compiler causing this problem, because they have been, this is older code. Okay, so what we have to do here, the error that we were getting, if I go ahead and if I make this, the error we're getting is that it doesn't know what average3 is. So I have to go up here and I have to specify. The syntax is a little strange. So you have to specify what the actual data type is of the average3 function. And it took it. All right, so let's see how this works. All right, so it said hello world 1. It doesn't really, that isn't really good. So we got 3, 4, 5, 5 divided by 3. That is 1. Let's put in some real numbers here. Let's put in 100, 120, 130. Let's try it again. And we get 83. So if you add 120, 130, you divide it by 3, I'm sure that you'll get 83. Another way you can do this is you can say print average of 100, 120, and 30 is. So you don't have to actually assign it to anything. And you can see it gave us this 101. Now I'm interesting, X, Y, and Z. Oh! X, Y, and Z. Well, we got a little bit of a problem here. So it says print Z. So yeah, we've got an issue. So let me see. So the average of 3. Let's actually do the math here. So we're going to take 100 plus 120 plus 30. Oh, I know why. So we divide that by 3. So our first one is correct. But also notice that we've got a fraction that we've lost. But we got 83. Now why is this 101? Because we overwrote Z with this assignment. So what we need to do is we need to say Z equals 30. Let's put it back to 30. And it's working correctly now. So pretty important. This is why you want to do a lot of testing of your code. So you can see what we did was we said that the average 3 function is going to be returning an integer. And we also said that these are the argument data types that average 3 is going to take. And then we simply specify this number. Now I'm kind of wondering if I go ahead and I change this to double. Let's do it on the same line. And the data type isn't actually double, it's actually real. Let's go ahead and do that. And you can see that we still did lose it because we've got 3 integers right here that are being that are actually taking our integers. So what happens is when we do this division, it's 3 integers divided by 3. Let's divide it by 3.0 and see what we get. And now we've actually got a valid number. So because we're dividing by 3, we're saying that this is going to be an integer division. And so when you divide something by an integer, you lose the decimal point. So even though these are integers, you can add them together because that's the first thing that happens in the equation. It adds those integers together. If you divide by 3 without the point 0, you're going to get an integer back no matter what you say the return type is of average 3. But if you say 3.0, that's a real. So divide our integers by a real and you get real because a real is higher priority than an integer. So something to be aware of, that these kind of statement functions can exist. You can imagine just how useful they are because you don't have to do a whole lot of coding. You do have to specify the data types and things like that, but you don't have the function statement, the end function, and all that kind of stuff. But they do exist on one line. Now you could continue it on the next line with an ampersand, but we won't go through that right now. So again, statement functions. Okay, very simple, quick little video on statement functions. Not used a whole lot, but I have seen it in code. I haven't seen it in a lot of new code, but I have seen it in some older code, and the compilers still support it. So another way of doing functions in FORTRAN.